Okay, so everyone should be everyone. I expect everyone should be familiar with these identities. So sine theta plus theta is sine theta cosine theta plus sine theta. Oh, sorry, cosine theta, sine theta. Okay, and that gives you 2 sine theta cosine theta. Okay, sine theta times cosine theta is the same thing as cosine theta times sine theta. So that's how you have 2. So you go ahead and write down 2 sine theta cosine theta right there. Okay. And then we have cosine of theta plus theta, and that is cosine theta times cosine theta minus sine theta times sine theta, and that is cosine square theta minus sine square theta. So we put it here. And yesterday I kind of previewed this already. I said that because we see sine square theta and cosine square theta, and last week we talked about the Pythagorean identities. So we say, well, sine square theta is equal to 1 minus cosine square theta. So that means we can replace sine square theta with that 1 minus cosine square theta. So to extend this, we can say, well, we can also write it as substitution. And you have a -1, and then you have a minus negative cosine square theta. That gives you 2 cosine square theta minus 1. So that would be the second version. 2 cosine square theta minus 1. And then we also know the other Pythagorean identity, which is cosine square theta. It's equal to 1 minus sine square theta. And we can now choose to substitute it over here. And then we say this is equal to 1 minus sine square theta minus sine square theta. And that gives you 1 minus 2 sine square theta. And that will be the third version of this cosine 2 theta. Okay, now just to give you a little taste of what this is. So I want you to see how we are not just dumping things to you, we're actually making things together. We are making things based on what we learned before. And I would say this gives you a much better taste of what calculus is like. I'll give you a little sneak preview of what calculus is like. For your first semester of calculus AB, it's all about slope, basically. You know, slope back in algebra 1. How do you calculate slope in algebra 1? Slope. How do you calculate slope? Not not where to use slope. Rise over run, right? Or if you have 2 coordinate points, y2 minus y1 over x2 minus x1. And I will tell you that this is what you would do for the first semester of calculus AB. For the most part of it. And you're like, really? That's easy. Well, it's the concept, it's really that easy. It's just that we try to make things more extensive, more applicable to some specific situations. So that may seem, or some people who don't understand the concepts, they would think like this is so difficult, but it's not. And for the second semester of AB, it's basically all about finding areas. Do you know how to find area of a rectangle? You're like, yeah, length times width, right? And yeah, it's just length times width. But it's just that not just one rectangle, but we're finding a lot of rectangles. So we'll learn some methods to do that. Okay. Tangent 2 theta is, well, tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. That is equal to 2 tangent theta over 1 minus tangent square theta. So 2 tangent theta over 1 minus tangent square theta. Okay. So again, there is nothing brand new. It's all coming from the addition of these angles, okay, for these trig functions. So now, so we say, hey guys, so if we have something like this, could you go ahead and simplify it? And we say, well, sure, that looks familiar. Sine x, cosine x, that looks familiar. We see this, we saw it somewhere up there, but there was a 2 up there, number 10. So we say, well, and this is why I kept saying, please make sure that you write equal sign, because if you know how to write the equal sign and you understand the meaning of the equal sign, then we say, hey, there's a number missing right here on the right. What number should be there? There should be a 5. Because that's how you get a 10. And once you get that done, then we'll be like, oh, so 2 sine x cosine x is simply sine of 2x. Right, this is sine of 2x. Done. That's it. Yes. Okay, so we're just like, okay, do you see the look? And if you see the look, then make it simple. Okay, it's like if I give you x squared minus 49, then you'd be like, oh, x plus 7, x minus 7, like that kind of sensitivity. All right, so let's look at part B. What bothers you here for part B? Yeah, no, so we can factor to 7. Okay, we say, oh yeah, you can see the 7 and 14. Let's go ahead and factor to 7. Hey, can you see something? That is cosine of 2x. Okay. All right. All right, now I'm going to let you try part C. Okay, I'm going to let you try part C yourself. It's pretty straightforward. 7 what? Look at the identity above. It's cosine of 2x, no, cosine square x. Okay, so you have to know your identities, then you know what to do. So for part C, so it looks like we have a 2 sine x cosine x, that kind of situation, except that it's not x, but rather it is 2x. So using the identity above, that would give you 3 times sine of how many x? 3 times sine of 4x. Because your so-called theta, it's now 2x. So 2 times theta would be 2 times 2x, which is 4x. So just make sure that you know, hey, that's your theta right here. So 2 times theta, it's 2 times 2x, so that gets you 4x. Okay. So should be pretty straightforward here. All righty. All right, now, so go ahead and take a look at the bottom one. All right, so we have these angles and stuff. It tells us that cosine of u is -5/13, and we have pi over 2 is less than u is less than pi. That means this is in which quadrant? U is in which quadrant? U is in quadrant. U is in quadrant 2. Okay, U is in quadrant 2. U is in quadrant 2. If U is in quadrant 2, then 2U must be in quadrant. No, actually, it could be 3 or it could be 4. Well, we'll see. Okay, we'll see how that number plays out. Okay, so so it tells us the cosine u. Well, sine 2u is 2 sine u cosine u. Okay, so now we have a similar situation that we encountered yesterday. We have cosine u right here, and we have the value to substitute in. And the dilemma, the challenge is that we do not have anything for sine u explicitly, so we have to create it. So it's in quadrant 2. Ooh, actually, let me draw it differently. So this is 5, this is 13, this is negative, this is the u, this is the right angle. So you have this angle in quadrant 2. That's -5/13. What is the opposite side in this case? It must be 12. And in that case, sine u would be 12/13, and tangent of u would be -12/5. Okay, well, we're going to use tangent over here in a moment. So now we can substitute in. Sine u is 12/13, and you just have to compute this fraction. Okay, so 2 times 12 times -5 will give you -120 over 169. Okay. Now, chances are you don't have to worry about canceling or simplifying the fraction, because if you could have done that earlier. And if you couldn't simplify anything earlier, that means there's nothing for you to simplify afterwards. Okay. So now go ahead, try it out using the identities above. Go ahead, try out the part B and part C. Okay. So for part B, now it doesn't matter which one you choose, they all should end up with the same value. So I'm just going to choose the first one, cosine square u minus sine square u, and cosine it's -5/13 square, and then sine it's 12/13 and the square. So that should give me 25/169. Minus, what is it called? Minus 144/169, and that is negative what? 119/169. Okay. So so if that's the case, if that is the case, that means 2 times u is likely located in quadrant 3, because both sine of 2u and cosine of 2u are negative. So it seems like we will expect a tangent that's positive. We'll see. We'll see if that's the case. Okay, so tangent of 2u is tangent of 2 tangent u over 1 minus tangent square u. So 2 times -12/5, 1 minus -12/5 square, and that is -24/5 And then 1 minus 144 over 25. That's equal to negative 24 over 5 over 119, negative 119 over 25. Okay, now the negative and negative would cancel out. So you have 1224 over 5 divided by the bottom fraction, meaning that you are multiplying by the reciprocal. So hopefully by now, everyone is very comfortable with these complex fractions. And so you go ahead and simplify. And we say, all right, so it's equal to 120 over 119. Okay. Pretty straightforward. All right, now, if everything's good, then you can stop right here for the moment. And the quiz material would actually stop right here. Originally, the plan was to include the next page material, but they made a decision this morning that we will not cover the half-angle identities for the quiz. We'll still go over it today, but we will not go over it on the quiz. So now, so here are a few angles, actually. Here are a few angles I want you to write down. So I want you to write down now next to the box, okay? You can write down the following angles, such as 75, 285, pi over 12, and 7 pi over 12. So if I ask you, can you use either a sum or a difference to express these angles? What would you write? Okay, give yourself a minute. Okay, think about the possibilities. Okay, you can list a couple or more if you can think of them. Okay, so 75 degrees would be, 285 degrees would be, all right, for 75 degrees, okay, we should think about this as louder. 30 degrees plus 45 degrees would be a very good one. Okay. Of course, you can definitely use some other things, okay, to get this. Yeah, I would just use this. Huh? You can do 120 minus 45. Yeah. Which one's better? The first one's better. Why? They're both in first quadrant. Okay. That means you do not have to worry about the signs. Okay. So for 285 degrees, what would it be? What could it be? Sorry. What could it be? We could think about this as, I can think about this as 240 plus 45. First students suggesting that it could be 135 plus 150. All right, these are angles that you're familiar with. Which one's better in this case? The what? The I would say the first one would be better, because you have a quadrant, one angle. So I would say whenever you have a quadrant, one angle, that kind of make your life easier because you have one less thing to worry about. You do not have to worry about the signs. For pi over 12, well, that's pretty straightforward. You can think about this as 4 pi minus 3 pi all over 12. Or you can also think about this as 3 pi over 12 minus 2 pi over 12. Okay. And you can reduce them. Now, I think the key that we went over yesterday was that, well, not yesterday, it's 2 days ago, is that if you do anything with tangents, if you do anything with tangents, you really want to stay away. You want to stay away from the anything with over 6. Okay. And for 7 pi over 12, 7 pi over 12 will be simply 3 pi over 12 plus 4 pi over 12. That'll be easy. Okay, both in quadrant 1. Okay, so we try to use quadrant 1 angles whenever possible, so that when we do all these sine, cosine, tangent, we do not have to worry about them. So expect that you will have to handle some of these angles. You have to do a sine or cosine of these angles. Okay, then use your identities to get the results. Okay, so yeah. All right, next up, next page. So the half angle identity, half angle identity. So yeah, speaking of the half angle identity, so that this one will always be given. Okay, so do not have to, you do not need to memorize them. They look something like this. Now, depending on what the angle is, where the angle is located, it could be plus or minus. It could be plus or minus of what? 1 plus cosine theta over 2. Okay, so that's the cosine theta over 2. 1 plus cosine theta over 2. Okay, and then sine theta, which is very similar to the one that we just wrote, it's 1 minus cosine theta. So the way I kind of memorize it is that cosine, it's kind of the normal one. So so this is plus. Sine's not the same as cosine, so that's a minus. And what do we know about tangent? Tangent is what? In terms of sine and cosine, tangent is sine of a cosine. If you put a sine of a cosine, you get, well, the denominator 2 would actually be canceled out. So you have this. Okay. So if you do sine of a cosine, then you have this fraction. The 2 got canceled out underneath the square root. So that's 3 little monsters to take care of. Okay. I think that should work. Okay. So so what we're trying to do now, if you look at the handout that I put on Schoology, there are actually other versions of tangent. Let me see. Let me see if you are responsible for the other ones. Yeah, actually you do. Let me go ahead and write this down too. So for tangent theta over 2, there are other 2 versions, and they are 1 minus cosine theta over sine theta. So the appearance, now the appearance of this is based on the multiplication of the conjugate here. Okay, so if you multiply by the conjugate of the denominator, so 1 plus cosine theta times 1 minus cosine theta, well, then you get sine square theta, or you get 1 minus cosine square theta, which is sine square theta. And then you have 1 minus cosine square theta multiplied by itself twice. Then you have the square root. Then you have this. And equally, you can multiply by the conjugate of the numerator. So you would get something just like this one on the left. But instead, you have sine square theta, sine theta on top, and 1 plus cosine theta in the bottom. Okay, so the appearance of these 2 is just basically from the multiplication of conjugate of this fraction. One is the multiplying the conjugate of the numerator. The other one is the multiplication of the conjugate of the denominator. Okay, so again, you do not need to memorize these. These will be given. So I think it's cool to know, but as I said, I have never used them in my life. I've never used them in my life other than teaching this topic. So that shows you how important it is. Not much. So what's going on? What's going to happen? Well, this is sine 15x, sine 15 degrees. So the way we look at it is that sine 15 degrees is the same thing as sine of 30 degrees divided by 2. Half of 30 degrees. So that allows us to use the identity, which is, well, in this case, it's in quadrant 1. So it's positive. So we don't have to write down the plus or minus because we know it has to be a plus. 1 minus cosine of 30 degrees all over 2. So it's going to be a little bit nasty here because you have to deal with a complex fraction again. So cosine 30 degrees is root 3 over 2 all over 2. So that gives you 2 minus root 3 over 2 all over 2. Now, when you write and create your complex fraction, make sure you be a little bit artistic in drawing these fraction lines. Make sure one is longer than the other so that you know which one's the bigger fraction. Which one's the smaller fraction? Yes. Common denominator. Okay. When you do common denominator, the 1 becomes 2 over 2. Now, I will show you how to get to the simplified fraction, but I would suggest you that you get more comfortable and try to do this mentally. So when we say this top fraction divided by 2, which is the top fraction multiplying by 1/2, which is 2 root 3, 2 minus root 3 over 4. So I would suggest you that you would skip this step. You would do this in your head and go straight to here. Okay, try to make it happen. That will serve you very well when you go to calculus. And that gives you 2 minus root 3 all underneath the gigantic square root over 2. Okay, so well, because sine 15 degrees is in the first quadrant. So we know it's positive. It has to be positive. Okay, it has to be positive. Now, if you ask me for sine 15 degrees, would I prefer to do this? Would I prefer to do this with a difference of angle or this half angle? I probably would say the difference of angle will be better. Like 45 minus 30 will be better than this, because like square root underneath the square root, that's just messy. Use the half angle identity to evaluate this. So so what is this? This is cosine of 7 pi over 6 all divided by 2. So your little theta is 7 pi over 6. So go ahead, try it out. Okay, go ahead and try it out. Okay, so we have cosine of 7 pi over 6 over 2. And that means we have the 1 plus cosine of 7 pi over 6 all over 2. And that is 1 plus negative root 3 over 2 over 2. And that is 2, well, no, 1 minus root 3 over 2 over 2. And then 2 minus root 3 over 2 all over 2. So you have square root of 2 minus root 3 over 4, which gives you square root of 2 minus root 3 over 2. Okay? All right. So now let's skip ahead. Let's try these guys right here. Okay, the bottom 4 questions. Can you match the looks right here and simplify the expression? Okay. Can you match the looks with the identities up there and simplify the expressions? Okay, for the first one, so that looks like a sine of an angle over 2. What's the angle here? That'll be 8x. Okay, that's an angle theta. So so 8x over 2 is 4x. Okay, so part A is just a sine of 4x. Part B, ooh, you see things both in numerator and denominator. I think that screams for tangent. And the theta is 12x, so theta divided by 2 is 6x. All right, part C, you have this plus right here. That means we are having a cosine of theta over 2. The theta is 10x, so therefore you have cosine of 5x. And this one is also screaming tangent right here, tangent. And this is tangent of 6x over 2, which is 3x. So fairly straightforward. Fairly straightforward. All right, now for the last part, I discovered, found out one thing, that on your notes it says 3/5, right? Change it to 5/3. I think when they updated the file, they forgot to change the fraction. So there's no way for secant to be 3/3. Yeah, there's no way for secant to be 3/5, because that's saying that, oh, the hypotenuse is 3 and the adjacent is 5. That's like nonsense. So it's 5/3. Now it's in quadrant 4. Okay, this is in quadrant 4. Now, well, what you realize is that for these half angles, we only care about cosine. So if you know secant u is 5 over 3, then that means cosine u would be 3 over 5. So if you know cosine u is 3 over 5, then you may go ahead and handle the following. You're like, oh yeah, sine u over 2, it's 1 minus cosine u over 2, and 1 minus 3/5 over 2. It's equal to 2/5 over 2, which equals to square root of 1/5. Now, usually we write it this way. If it's a square root of 1/5, it becomes 1 over square root of 5. And after rationalization, that becomes square root 5 over 5. Okay. And for tangent, we have square root of 1 minus cosine of u over 1 plus cosine of u. Okay. And by the way, it will be a negative value. Why? Why is it negative? Well, u, it's in quadrant 4. And if u is being divided by 2, that means it should be an angle in quadrant 2. And tangent of an angle in quadrant 2 will be negative. So that's how we know it's a negative. So 1 minus 3/5 fifths over 1 plus 3/5. So that gives you 2 over 5 over 8 over 5. The 5 would actually get canceled out. The 2 and the 8 would simplify to 1/4. So that is a square root of 1/4, which is simply 1/2. Okay. So making sure that you know how to handle the values, handle the fractions. As I said 2 days ago, materials here is not that hard. I mean, the memorization of the identities for the past 2 days, you know it. If you spend time on it, you will know them. Substitution is not hard. The hardest part is, do you have the fundamental skills in handling fractions, complex fractions, square roots? Okay, so that's how people know that. That's how you get ready for calculus, is to have all these little skills. Okay, well trained. Then when you go to calculus, you're like, oh, I know all these things. There's no problem at all. Okay.